What really goes on inside black holes? The James Webb Space Telescope has just captured the first real image of the inside of a black hole, and we may be on the verge of unraveling this important question in astronomy. James Webb's latest discoveries suggest that black holes played a far more crucial role in the formation of the universe than previously thought. Our understanding of the early universe has expanded dramatically since the James Webb Space Telescope allowed us to peer into the vastness of space. Instead of seeing what scientists had predicted, we are witnessing phenomena that are far more exciting than any theory. The James Webb Space Telescope is the most advanced space telescope ever built. With the help of this masterpiece of human engineering, we can continue to satisfy our scientific curiosity and illuminate corners of the universe that were previously in the dark. Since its commissioning, the JWST has revealed completely new details about the birth of stars and galaxies and has shown us what may be the oldest black holes in the universe. These mysterious cosmic phenomena are so dense and massive that they bend spacetime to an extreme degree. This curvature alone gives them a key role in the universe. The curvature of spacetime is the cause of gravity, the force that causes gigantic objects to move towards each other, galaxies to dance, and us to stand upright on our planet with our feet. Black holes were pure theory until Albert Einstein and some of his contemporaries predicted them mathematically. It was not until the 1960s that the first black hole was detected via a radio telescope, and we had to wait another 40 years for the first image of a black hole. Black holes themselves are invisible. They consist of a type of matter and force that has great weight but emits no or only minimal light. Thus, these giants would not be visible to our eyes if not for two circumstances. Firstly, black holes become visible due to their massive weight, and secondly, they often have accretion disks around them. When they dissolve and finally swallow up matter in their surroundings, this matter glows brightly around the black hole's event horizon. The light can be so extreme that it shines as brightly as a galaxy. Very large black holes, in particular, which can be millions or billions of times larger than our Sun and dissolve a lot of matter, often shine very brightly and are visible from a great distance. What passes beyond the event horizon of a black hole was long considered lost. However, we now know that complex things must happen inside a black hole. Matter can never be completely destroyed, that is a law of physics, but what happens to the matter inside a black hole? The James Webb Space Telescope will rise to the challenge and complete our understanding of the true nature of black holes. What information do black holes give us? Can you imagine the gravitational pull of a black hole? Just imagine a mega-powerful vacuum cleaner and a spring. The suction force of the vacuum cleaner will pull a feather in like nothing and it has no chance of escaping. This is what happens to entire star systems that come into the vicinity of black holes. Once they are within the catchment area of such a giant, their fate is sealed. The enormous forces outside the black hole begin to slowly pull the matter apart like spaghetti. Physicists say that nothing that gets beyond the actual event horizon can escape the hole. However, this is actually impossible if matter only comes close to the hole beyond the event horizon. Horizon lies the physical point of no return. No force in the universe could bring anything back here. Then, the path of matter, or rather what is left of it, only goes in one direction, into the black hole and directly towards its center. The formation of a black hole is an equally dramatic event. When a massive star collapses at the end of its life cycle, it can collapse under its own gravity and form a black hole. This process leaves a tiny point in space where the density is infinite. This point is known as a singularity and forms the heart of the black hole, surrounded by the event horizon. We know what goes on inside from mathematical equations and theoretical experiments, but we have never seen it. Our calculations have shown that all known forces inside the hole move towards infinity. Black holes are therefore not only the endpoints of stellar evolution but also the key to understanding the fundamental physics of the universe. They represent a boundary at which our ideas of space and time reach their limits. Researchers, therefore, suspect that these objects are important keys to understanding the laws of physics. What did James Webb discover inside the black hole? It sounds crazy, but it's true. James Webb discovered one of the largest black holes ever sighted, at a distance of 13.3 billion light-years. This discovery is incredible, as the universe was supposed to have been very young at the time. Black holes form after the death of a star and then grow by annihilating other stars or by merging with other black holes. The ultramassive black hole that Webb shows us contains more than 1 billion solar masses. The scientific problem with this discovery is that it existed at a time when there should only have been first protostars. This means that this black hole could not possibly have already consumed more than 1 billion stars, but it is real and has become a universe breaker alongside some very old galaxies. The discovery of these old and large objects turns our previous cosmology on its head. So, what can James Webb find out about the black giants? Named after James E. Webb, a pioneer of American space travel, the telescope has been equipped with only the finest and most advanced technology. It has been specially developed to unravel the very secrets of the early universe, to study the formation of stars and planetary systems, to analyze the atmospheres of distant exoplanets, and to bring us closer to the nature of black holes. To this end, the JWST has four main instruments: the NIRCam, the NIRSpec, MIRI, and FGS-NIR. These instruments allow the telescope to observe light in near and infrared regions that are invisible to the human eye. This capability allows the JWST to detect objects that are cold, very distant, or obscured by cosmic dust. The telescope's position at the Lagrange point L2, about 1.5 million kilometers from Earth, minimizes light pollution and allows for almost uninterrupted observation of the universe. To protect the sensitive instruments from the sun, the JWST has a huge sunshade the size of a tennis court, a key feature of the JWST. Research into black holes is supported by its huge gold-coated primary mirror with a diameter of 6.5 meters. This mirror collects light over wide areas of the electromagnetic spectrum. Compared to its predecessor, the Hubble Space Telescope, the JWST can see objects that are up to 100 times fainter. In the case of the 13.3 billion-year-old black hole, Webb did not have to go to such lengths as the accretion disk shone brightly. The JWST discovers 6 ancient black holes. Let's dive a little deeper into the fascinating discoveries JWST has made about black holes. The new discoveries not only expand our understanding of these mysterious objects but also challenge us to rethink our theories about the origin and evolution of the universe. The very old black hole shows us that these objects existed much earlier in the universe than we assumed. This also raises questions about whether black holes can possibly be created in other ways. Experiments have shown that black giants can also be formed by the direct collapse of a disk of gas and dust. One of the first highlights of the JWST was the detailed observation of accretion disks around black holes. These disks, consisting of gas, dust, and stellar remnants that are pulled into the black hole, could be imaged with unprecedented clarity. These observations provide valuable data on the physics of matter accretion and energy emission near the event horizon. Based on the matter around the hole, we can understand what the black hole is sucking in. This, in turn, allows us to draw conclusions about the black hole's environment. The JWST has discovered 6 more supermassive black holes located in the centers of galaxies. First images of impressive jet ejections could give us insight into how old galaxies with active centers evolved and how they influenced their environment. Jets are huge bursts of radiation and winds that extend thousands of light-years into space. They probably have a significant influence on star formation and the chemical composition of their home galaxies. They may even influence other galaxies in the vicinity and the space in between. For the first time, the Webb telescope allows the detailed study of the immediate surroundings of supermassive black holes. By analyzing precise data on the motion of stars and gas in the vicinity of these cosmic giants, astronomers can better investigate the mass and rotational speed of galactic nuclei and thus understand the dynamic processes of galaxies as a whole. These new opportunities and discoveries mark just the beginning of the James Webb Space Telescope's journey. Each new observation offers unique insights into the nature of black holes and helps to unravel the great mysteries of the universe. However, black holes are not only known as active galaxy centers, many of them migrate through their galaxies. The discovery of such a wandering black hole in a distant galaxy offers unique insights into the dynamics that these giants unfold outside of galaxy centers. Gravitational lensing reveals the oldest stars. Did you know that black holes make it possible to observe the oldest stars and galaxies? The effect is called gravitational lensing. Due to their extreme weight, supermassive black holes distort spacetime in such a way that it acts like a lens. At these points, the light from objects behind black holes is thus bent and stretched, making it more visible to the JWST. In this way, we have already been able to see some of the oldest individual stars that would have never been visible without this effect. Researchers are currently considering how the gravitational lensing effect can be used even more specifically in the future to visualize even older objects in the universe. So far, the effect has mostly occurred by chance. However, we could also use very large and massive black holes as gigantic cosmic magnifying glasses to look even deeper into the cosmos and unlock even more secrets from the universe. Click the subscribe button now and be part of many new videos.